Okay, Natalie, so for 21, first you're going to have to figure out the distance on like from A to B and then A to D and A to C because you have those coordinates to figure out the distance for. And then you can use those to set up your proportion to see what distance you need from A to E. Does that make sense? So what we're looking at there, we've got to, well, we've got to set up proportions, right? So if you can figure out the distance between A to B and A to D because you have those two, you have coordinates for those 2 points, right? So if you assign those coordinates to it, then you can really, you don't even have to use the distance formula. You can just count because they're both on the axis. And then the same thing for the distance from A to C. And then you're just going to use those numbers to set up your proportions, then cross multiply and divide. Does that make sense? Madison, does that help you with number 22? Okay, good. Yeah, Charlotte Ann, for 17 and 18 on the practice A, the key thing on those two diagrams that you need to look at is to see that they have parallel lines that are marked. And then you're going to have to go back to what we know about, like number 17 would be, what do we know about angles that are formed when you have two parallel lines cut by a transversal? All right. And then for number 18, we have those two parallel lines again, and you could say that those sides of the triangle, like QS and US, that those are transversals. So you can kind of look and see what relationships you have for those angles as well. Lily, did you need number 18 on the worksheet? Bookwork. Okay, hold on. Okay, Lily, so for number 18, it wants you to draw a diagram that would kind of prove number 18 wrong. Okay, so what it says is that if two pairs of sides of two triangles are congruent, then the triangles are similar. But what it doesn't say is anything about the angles, right? So if you take, and you're going to draw a triangle, say like this, where you have 2 and 3 as the sides. You could take the same 2 and 3 and draw them with a bigger angle. You still have the same measurements for the sides, but the angles are different. So those triangles would not be proportional there. Does that make sense? You're welcome. Campbell, for 19 through 21 on the worksheet, you're going to have to look at the pictures and see how can you tell that they're similar. So for 19, what do you see? Yeah, that's what you'll use for 19 because that's marked. Now on 20 and 21, there's no angles that are marked. So how do you know that you can show angles are congruent on those two? You need to focus on the lines that are marked parallel there. Okay? Yeah. So tell me on 20 and 21, your answer should be some kind of explanation of how you know that angles are congruent in there. Okay? Worksheet or bookwork, Lily? Okay, hold on. Sorry, Campbell, I forgot about those. Hold on just a second. So, Lily, on number 12, you need to determine if they are similar, and then if they are, write a similarity statement. So, we see here that we have this angle and this angle. Those are congruent, right? Do you see any other angle in those two triangles that you could say is congruent? Well, we don't know angle E and D for sure, but check out those. If you draw those triangles separately, you have angle or triangle BDC, right? BDC. And then you have the big triangle. Sorry, I should probably do that not upside down. AEC. So do you see an angle that they share? So that angle, since it's the exact same angle in both triangles, that would be the other angle that they need to be able to prove them similar. Okay? Campbell, let me pull up the image for those problems, okay? Lily, remember your similarity statement is the letters of the triangles. Yeah, like what Campbell said. It would be the letters of the two that are similar to each other, okay? And it needs to have the corresponding angles in the right spots. Remember, order matters on that. Okay, Campbell, so for number 20, do we have enough information to say that those two triangles are similar? So then what you need to do is set up your similarity statement. And then you're going to solve for x. Or sorry, not similarity statement, your proportion. You'll use your scale factor, set up a proportion for those sides, and solve for x. And then you're going to take that and plug it back in, or take that and add it to the 5 so that you have the whole length of BD. Does that make sense? Okay, so which angles do you have are similar to each other then? Okay, the vertical angles, but in order to say that those are similar, you've got to have another angle that's congruent also, right? So which angle goes with angle B? And then A and C would go together? So what scale factor did you use then? Okay, 5 and 4 are not the corresponding sides there. Yeah, it'd be 5 over x. Not 4 over 3. 5 came from the bottom triangle, so 3 needs to be on top because it also comes from the bottom triangle. Does that make sense? Okay. Do you see why they go together that way? Okay. And then for 21 through 24, you're going to need to set up proportions using the distance from A to B, A to D, A to C, and then you're going to solve for A to E. Yeah. Well, you don't really have to use the distance formula because if you look at them, they're all on the axis. So it's really just counting. Did I miss anyone else's questions? So Campbell, on that, you have to figure out what the corresponding sides are for the two triangles. You see that you have two triangles there in the picture? Okay. Let's see. You also asked about number 25, right? And then Charlotte Ann, I'll get to yours too. So Campbell, did you mark up the picture with all of the information that's listed in the beginning? So if you wrote down, you marked your two parallel lines, then you have transversals there. So you can mark congruent angles from that, right? So that should help you be able to do part B. And then if you have two triangles that you've proved two angles are similar in those triangles, that should be able to help you do C. And then for D, you'll have to set up a proportion with the measurements that it gives you. Okay? You're welcome. Okay, Charlotte Ann, 17 and 34. Hold on just a second. Okay, Charlotte Ann, so for number 17, you're supposed to tell why the student got their calculation for X incorrectly. Now, look at the two triangles that are in that picture that you're supposed to be proving similar. Do you see, where did they get the 5? What whole side of the triangle is equal to 5? So do you see why that's wrong? What it should be instead? Okay. And then give me a second for number 34. Okay, so Charlotte Ann, this is 34, and Lily, this is 34 also for you. So if we look at this problem, low-level aerial photos can be taken using a remote-controlled camera suspended from a blimp. You want to take an aerial photo that covers a ground distance, g, of 50 meters. Use the proportion F over h equals n over g to estimate the altitude h that the blimp should fly at to take the photo. In your proportion, you're going to use F equals 8 and n equals 3. These two variables are determined by the type of the camera that's used. Okay, so if you look at your diagram, they're telling you for your proportion, you're going to use this F over h and n over g, right? They want your ground distance to be 50 meters. They tell you the F and the N also. So you're just going to plug into that proportion to solve. Does that make sense? Lily, does that make sense for you? Well, we're doing F over H equals N over G, right? So in the problem, what's the value for F? And then for N? No, Megan, on this one, you don't have to convert because both of the tops are in the same unit. And then we want the bottom to be in the same unit as each other. Because basically what's going to happen, those units for the F and G are going to cancel out. Or sorry, not F and G. So when you cross multiply here and then divide by that, that centimeter unit's going to cancel out and leave you with meters. And then there was one other problem. Let's see, 31, Lily. So Isabel, on that one, the 3 doesn't cancel out, but the centimeters do. So what we have here is 20 over something. What side corresponds to the 20 on the bigger triangle? Okay, so on your bigger triangle, the one that's made where the puck is, what side of that triangle is the same or is the corresponding side to the 20 on the other triangle? D, okay? So we'll have 20 over D, right? Small over big. And then we have 26 inches, which is from our small. And do we know a measurement for that one? Can we figure out a measurement for that? Well, we know that the whole length there is 66, right? But if you look at that, that 66 includes the 26. So then what's the distance just of that part I circled of the bigger triangle? Well, 26 is the distance for the small triangle, right? It's from here to here. We need to know what this part is. So if this whole thing is 66 and this little part of it is 26, what's this part? Yes. Does that make sense? Oh, okay. Five and six on the worksheet, Charlotte Ann. So for 5 and 6, the work for those is already shown in number 3 and number 4, right? So you just have to solve that. Does that make sense? Okay. And then number 22. So for number 22, you got to look at that diagram there, okay, and see what your two triangles are that you're looking at to try to prove that they're similar. And mark the given information, okay? Then see what you can prove to show that you have similar angles or congruent angles, sorry, two congruent angles, so that you can prove that those two triangles are similar. Does that make sense? So what you'll need is you'll need to know what the definition of a midsegment is so that you can see how it helps you prove all of that. And you don't have to, remember, you don't have to write out the whole 2-column proof, okay? Just kind of give an explanation of how you got there. Yeah, Isabel, so for number 12 on the worksheet, when we're looking at that diagram there, you have one triangle, triangle ABC, and it shows you that you have two angles that are congruent there, right? So then the next triangle, DEF, shows you that you have two congruent sides. So if you look, do you remember what we know about isosceles triangles when they have two congruent sides? Yes, the angles opposite those congruent sides are also congruent. Now, we know that the interior angles of a triangle add up to 180, right? And both of these triangles pictured are right triangles. So if we take away the 90 degrees from that right angle, we know that the other two angles in both triangles are congruent to each other. And that only leaves us with 90 degrees left to divide between the two angles in each triangle. So if you do 90 divided by 2, will that give you the same answer for both triangles? Okay, so does that make sense why those are similar? Okay, so let's see, 12, 13. So 13 is going to be the same type of thing, okay? Those are both isosceles triangles, so use what you know about them. And then number 16, use the fact that you know the interior angles of a triangle add up to 180. And then you can see that you'll have two right triangles there, okay? Does that make sense for number 16? Okay, good. So Madison, for 6.4, that's proving that triangles are similar by side, 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 and side angle side. So did you watch that video that covers 6.3 and 6.4? Okay. So that's what 6.4 is over. It's proving similarity, knowing that you have side angle and side or side, side, side. So number 8 on the worksheet, Charlotte Ann, those are what type of triangles? Or what type of triangle is the one that's shown there? And with an isosceles triangle, what do we know about those two base angles? So then you can figure out that third angle, right? So then you can figure out the missing angles on those other triangles and see if they're similar. Does that make sense? Okay, good. Megan, let me pull up number 19, okay? Well, that didn't pull up. Let me try again. Okay, so for 19, it says, if the ratios of two pairs of sides of two triangles are proportional, then can we prove that the triangles are similar? We need to figure out or draw a picture that will disprove that, right? So if I draw a triangle that looks like this, and say this is 3 and this is 5, and then I draw a triangle that looks like this, and this is 3 and this is 5. Or even you could say that this is 6 and this is 10, okay? This side here could be a different measurement. It could be not proportional because the angle could change here, okay? Does that make sense? You're welcome. So Madison, number 19 on the worksheet, if you look at that, do you have enough information in the picture already to tell you that the triangles are similar? Okay, so you're going to explain that because of the marks, you can prove that they're similar and then tell why. Tell what reason you know that they are. And then Charlotte Ann, number 31. I worked that one with Lily just a minute ago. So if you look at that picture, okay? If you notice across the bottom there, you have the one distance of 26, and then you have the whole distance of 66. So what you need to do is see if you can figure out what that other distance is using those two. You see how to do that? So what would be the distance of that other triangle down on the bottom? Yes. So then you'll set up your proportions using that number. Does that make sense? Okay, good.